Hello, my name is Arun Patel, and I have worked with the Pulse Electronics parent company Technitrol uh, since 1965. Technitrol was formed in 1947 by four engineers from University of Pennsylvania who worked on a very first electronic computer ENIAC at university, and after starting the company they provided a lot of engineering expertise to uh, uh, University of Pennsylvania. I joined the company in '65, and we were working with the IBM on their core memory for their mainframe computer, and we were making like a pulse transformer for core memory driver in the order of 25,000 a week, and we didn't have any way to automatically test the passive components, so we acquired a semiconductor test system, and I converted the passive component measurement to a pulse measurement using that system, and we were able to use a semiconductor test system to do the automatic test measurement. In early 70s, the core memory was phased out by a dynamic DRAM memory, and for that they needed a timing modules which can access row and column, and we were instrumental in developing a semiconductor delay line which combines the logic of a TTL logic level and a passive delay line, and provides a timing module. And I worked with one of the founder chairman of the company, and these are actually his handwriting. I was developing the component, and he was recording and doing some outside work for me by graphing it and all that, and I'm really proud of that, working with him. And we developed and we were making this TTL module also in a order of 10 or 15,000 a week for Bell Lab, AT&T. Bell Lab and AT&T. In the 80s, we were involved in a serial data transmission at the high speed of megabit, 2 megabit, and 50 megabit. And I developed a MEDM module using our delay line to decode the data, and we were able to provide Bell Lab with the very first MEDM module to transmit 2.02 gigabit data rate over a T1 even line. And at the same time, I worked with the DESI and Defense Supply Center in developing the delay line, active delay line and passive delay line QPL specification. Right now we are the only QPL delay line supplier. I know the delay line is okay. Now in '95 we acquired, Technitrol acquired Filmag and then Pulse, and we became the Pulse Electronic Corporation, and Pulse was very big in Ethernet area and I started working with the Ethernet area, and Ethernet area in 2000. Yeah, Ethernet area, and at the same time I started working with the IEEE fiber channel working group, developing a specification for 1 gigabit. Ethernet was 100 megabit at that time, but we were developing a 1 gigabit serial transmission using a fiber channel protocol, and we worked with the IEEE in developing those specs, and from that specification we developed a transceiver module which can go from 266 megabit to 1.062 gigabit fiber channel data rate. In 2003, Pulse was awarded a patent, and I was the inventor of that patent for high bandwidth high bandwidth module, where we can take a 50 ohm system and convert into 100 ohm 100 ohm impedance balance, and we were awarded a patent on that in 2003. And from that high speed balance, we developed a balance which can work at 1.485 gigabit data rate of SAMT high speed HD TV and ultra high speed UD TV TV transmission, and right now we have a transceiver module which can transmit at 1.482 gigabit for high speed data transmission for HD TV, and we are working on at presently. We just acquire, we will acquire this new instrument which will go up to 3 gigabit and higher serial transmission testing, and hopefully we will surpass the 3.3 gigabit transmission rate. At present it looks like that 3 gigabit would be the high threshold for a digital transmission over a copper media.